Good day everyone. So for today we're going to discuss all about limiting and excess reagent. Okay, so when we say limiting reagent or reactant, it is a reactant that is consumed completely in a chemical reaction. Okay, so excess reagent on the other side is a reactant that will have some unreacted amount after a chemical reaction. To help you understand the concept of limiting and excess reactants, consider the analogy shown in Figure 1. Here we can see that 1 serving of fruit salad require 1 apple, 1 peach, and 2 kiwis. If you have on hand 10 kiwis, 5 apples, and 4 peaches, how many servings of fruit salad can you make? From the figure, you can see that 4 servings of fruit salad can be prepared from the number of fruits available. The number of servings is limited by the available numbers of peaches. Also, 1 apple and 2 kiwis are left in excess in making the 4 servings of fruit salad. Always remember that chemical reactions can be viewed in the same way. Consider the reaction between nitrogen N2 and hydrogen H2 to form ammonia NH3. If for example at the start of the reaction, 3 N2 molecules and 3 H2 molecules are present, how many molecules of NH3 can be formed? You can visualize that initially all N2 and H2 molecules are separated into individual atoms. These are the atoms available to make NH3 molecules just like the apples, peaches, and kiwis before they were used to make fruit salad. In Figure 2, you see that 1 nitrogen atom and 3 hydrogen atom are required to make 1 molecule of NH3. If initially you have 3 N2 molecules or 6 nitrogen atoms and 3 H2 molecules or 6 hydrogen atoms, you can make 2 NH3 molecules having 2 N2 molecules or 4 nitrogen atoms left in excess. The amount of NH3 produces is limited by the amount of H2 molecules present. Therefore, H2 is the limiting reactant while N2 is the excess reactant. Okay, sample problem number 1. Tetraphosphorus dicoxide P4O10 is formed from the reaction between solid white phosphorus and oxygen. If 25.0 gram of phosphorus P4 and 50.0 gram of oxygen are initially used to form P4O10, so here are the following question. A. Which is the limiting reactant and which is the excess reactant? B. How many grams of P4O10 are produced? C. How much of the excess reactant are left after the reaction? Okay, so here's a given. So we have mass of phosphorus is equal to 25.0 grams. And then mass of oxygen is equal to 50.0 grams. Okay, so for the required or the unknown in the given problem, so we need to find first the limiting and excess reagent or reactant. Next, we need to determine the number of grams of P4O10 produced in grams, and then next, we need to know how much of excess reactant or the amount of excess reactant are left after the reaction. Okay, so here are the strategies we need to follow in order to solve for the limiting and excess reagent. Step 1. Write a balanced equation for the reaction. Step 2. Determine which is the limiting reactant. Always remember that the limiting reactant limits the amount of the product formed. So, to determine which between P4 and O2 is limiting, compute the amount of P4O10 formed based on the amounts of P4 and O2 given. The reactant that will give the lower amount of the product is the limiting reagent. Use your knowledge on mole concept and mole ratios to do this step. Step 3. To know the amount of excess reagent left after the reaction, compute the amount of excess reagent that is actually used based on the amount of the limiting reagent or the amount of product formed. Subtract the actual amount of the excess reagent used from the initial amount given. Okay, so here's the equation we're going to use. Mass of substance A multiplied by 1 mole substance A divided by molar mass substance A multiplied by number of moles substance B divided by number of moles substance A multiplied by molar mass substance B divided by 1 mole substance B. Okay, next for the solution, we're just going to substitute the given value. So we have 25.0 gram P4 multiplied by 1 mole P4 divided by 123.9 gram P4 multiplied by 1 mole P4 O10 divided by 1 mole P4 multiplied by to 83.9 grams P4O10 divided by 1 mole P4O10. All in all, it is equal to 57.3 gram P4O10. So, you just need to cancel the like units. And then next, another solution for the amount of product formed when all O2 is consumed. So we have 50.0 gram O2 multiplied by 1 mole O2 divided by 32.0 gram O2 multiplied by 1 mole P4O10 divided by 5 mole O2 multiplied by 283.9 gram P4O10 divided by 1 mole P4O10. So all in all, it is equal to 88.7 grams P4O10. So you're just going to cancel out the like units. Since the mass of P4O10 produced when all P4 is consumed is less than the mass when O2 is used, the limiting reactant is P4, while the excess reactant is O2, and then the amount of the product formed is based on the limiting reactant. Thus, 57.3 grams of P4O10 will be produced. When this amount of P4O10 is produced, the reaction will stop, leaving an amount of the excess reactant O2 unreacted. Okay, next, the amount of O2 that will react with the limiting reactant P4 is 25.0 grams P4 multiplied by 1 mole P4 divided by 123.9 grams P4 multiplied by 5 moles O2 divided by 1 mole P4 multiplied by 32.0 grams O2 divided by 1 mole O2. So all in all, it is equal to 32.3 grams O2. Okay, so the excess amount of O2 left is equal to 50.0 grams minus 32.3 grams is equal to 17.7 grams excess O2. Okay, so again, this is Miss Joanne Orentein, your Gen Chem teacher. Thanks for watching.